Hello and welcome. In today's class, we will look at a question based on binary search, and we will be implementing binary search using recursive technique. This question is taken from ISC Computer Science 2015 theory paper. According to the question, we have to create a class admission that contains the admission number of 100 students. And the data members and the member functions are given below for this class. As you can see, we have a variable admission number, which is actually an array to store the admission numbers as integer values. We have a constructor to initialize the array elements. One fill array function is also there to input the elements into the array in ascending order. And we have a function called binary search that is going to return either 1 or -1. It will return 1 when the element is found or when the admission number is found. Otherwise, it will return -1. So we have to specify the class admission giving details of the constructor, void fill array function, binary search function. We also need to define the main function to create an object and call the functions accordingly to enable the task. So let's begin writing the program for this question. So I have created a file here called admission.java. So let's start with the import statement. We have imported the scanner class. Now we define the class admission. We have a data member, one array variable. Then we have a constructor. To initialize the array, so we write new int 100. Because in the question it is already told that we have to store 100 admission numbers. And that's why we are keeping the array size as 100. Next, we have a function called fill array. To fill the admission numbers into the array. And because we'll be doing input here, we need to create the scanner object inside this function. So we write scanner in equals new scanner system.in. Now we have to give a message first of all to the user that the admission number should be entered in ascending order. So we write system.out.println enter admission numbers in ascending order. And now we run a for loop that will go through the entire array. But I++ will only take place on one condition, when the elements are being entered in the right order, in ascending order. So we are not writing I++ here. First of all, what we'll do, we will give a message admission number I+1 and we input it in a variable a. So we have given I+1 here because when I is 0, it will display admission number 1. When I is 1, it will actually display admission number 2 and so on, so that the user can understand which admission number is being entered. Now, if this is the first admission number, So if I write if I is 0, that means we are entering the admission number for the first time. So in that case, we just put it in the array. Else if A happens to be less than or equal to the previous admission number, I minus 1, then it's an invalid admission number, because we are not going to take values in descending order. We only have to take elements in ascending order. So the next value cannot be less than or equal to. Not equal to also, because two admission numbers cannot be the same. So if there's a problem, once again, admission number has to be entered, and so we write continue. So once again, this loop will repeat and admission number will be asked for that particular index only, because we have not incremented the index number in this case. Else, admission number I plus plus equals A. So this is how we can write the fill array function, so that the elements are always entered in ascending order. As you can see, we are not using any sorting technique. We are just making sure that the user enters values in ascending order. If the first value is entered, there is no need to do any comparison, because that's the only value we have right now. So we straight away put it in the array. But if it is second value, third value, and so on, then in that case, first of all, we check whether the value of A is less than or equal to the previous value or not. If so, then we tell the user to enter the admission number again for that particular place. Otherwise, we simply receive that value in the array. So our fill array function is complete, and now we can create the binary search function. So now we write public int binary search lower value, upper value, and the value that we need to search. Now we know that in a binary search, the searching always starts from the middle position of the array. So we first of all find the value of mid as low plus upper by 2. Now before searching, first of all, we have to make sure that L is not greater than U, because if that's true, that means the element is not present in the array. So we write return -1 if that's the case. Otherwise, if the value is found in the middle element, then we return 1. If value is less than admission number in the middle, that means we need to carry on our search on the left half of the array. So we write return binary search L, so upper will change to mid -1 and V. All of these conditions, if these are false, then we straight away return. That means we have to proceed. Only one possibility is left to be considered, that we have to proceed to the right half of the array. So we write return binary search. We have to carry on our search on the right half. So we write M plus 1 upper and V. So this is our binary search function. Now, because we will be checking this program, we are not going to waste our time entering 100 elements. So we will change this to 5 for now. And now we can begin writing our main function. In main, we will create an object of admission class. Now here also we need to input the element that we want to search. So here also the scanner object is required. Now first of all, we call the fill array function. Once all the elements are entered into the array, we can now ask the user to enter the admission number to be searched. So int v equals integer dot parseInt in dot next line. And within if condition, we call the binary search function. So obj dot binary search. The lower index will be 0. Upper index will be 4 in our case here because I have changed the size to 5. So we will write 4 over here as the last index. But if you're using 100 over here, then it should be 99. And the value that we want to search. If it returns 1, then we print let's say present, else we print not present. So that's our program. Let's check the output now. So you can see firstly it's giving us a message that we have to enter admission number in ascending order, and it is asking for admission number 1. So let's say I have given the admission number as 105. Now if I try to give a lower value than 105, let's say 103, it is again asking me for admission number 2. If I give the same value, then also it's not going to accept. Again, it's going to ask me admission number 2 because I is not incrementing as long as I don't give a valid value. So now if I give 106, it is accepting. Then let's say 125, accepting. Again, if I give 114, it is not accepting. So now 130, let's say, and 132. Now it is asking for the admission number to be searched. So if I give, let's say 130, so it is showing present. So I hope you have understood how to implement binary search using recursive technique. And you have also understood how to make sure that the user enters values into the array in ascending order without using any sorting technique. So that's all in this class. Thanks for watching. See you in the next class.